pretty much all of you have been here, but I do see one or two new faces, so I haven't heard much spiel in a really long time. So basically, this is a seminar series that provides a venue to learn about and discuss new tools, technologies, methodologies, approaches of tools and technologies. They can be newly developed, they can be in development, they could just be something that's been around a long time, maybe used in a different way. So there is a sign-in sheet going around. Please sign it. It helps with the pizza, and we all love our pizza, so I do appreciate it if you sign in. I want to mention again that there has been a change in the speaker for February 25th from the originally announced speaker. We have changed that, and there's no longer going to be a seminar on May 5th at this time. So with that, I'd like to introduce our speaker. I'm pleased to present Margaret Hedstrom, who's going to talk to us about seed.
Okay. Thank you, Marcy. Thanks for the invitation. I finally made it over here to talk about seed. I guess I'd like to start with a question. How many of you are PIs on government-sponsored research?
Not right now.
Not right now. One person. How many of you are students? How many of you know what a data management plan is? Few of you. Okay. There's been a big push policy-wise in terms of science to take advantage of the investments in the production of data and making data more accessible and reusable, accessible to the public and reusable by scientists who may be able to extract some new knowledge out of data or combine it with other data and gain some new insights, or to evaluate and replicate the results of research. And this crosses pretty much every field of science. And that is the kind of problem that SEED was designed to address. So I want to give you today a quick overview of what SEED is and not go into a deep under the hood explanation of how it all works and fits together. But I want to talk a bit about the kind of niche that it is trying to fill and what some of the things are that anybody can do with SEED if they are interested. So, SEED offers a whole set of powerful tools that help scientists share data as they're creating it, to manage data as they are analyzing it, to curate data, and to publish data to a repository if they wish, where it will be kept securely for the long term. And I want to say a little bit about, this is a little hard for me from here. I want to say a little bit about the issues that SEED is trying to address. So we were funded by the National Science Foundation. Actually, we still are funded by the National Science Foundation under a cooperative agreement with University of Michigan is the lead, and I'm the PI on the project. But we also have teams working at University of Illinois, and at Indiana University. And we're funded under something called the DataNet program, which was explicitly set up to fund research and innovation around data access and preservation. And what we were looking at as part of this larger program was how to help the researchers out in what we call the long tail. So many of the investments in data management have been oriented to these large petascale data collections, things like the Sloan Digital Sky Survey, the data coming out of places like CERN, where you have very large collections of relatively heterogeneous data. They're typically of the same format, but they're just very large volumes of them. And these data tend to be under relatively secure, or at least organized, stewardship. There's a lot of data out in the long tail where there's no provision for how do you manage your data when you have come up with a finding or a result. Where do you publish your data? And most importantly, how do you archive it for the long term? So SEED was, SEED was designed, I'm going the wrong way here, to help researchers, for one thing, who have to analyze really heterogeneous data or multiple types of data. And that could be, image data, sensor data, data that is numeric in spreadsheets, models. There's just lots of different data types that, when combined, are much more valuable than they are standing alone. And so we have provided some tools that we think make it easier to do that. We're also looking at researchers who need to collaborate to make scientific advances. How many of you work all by yourself? Okay, that's what I figured. Typically in science is now team science, and groups of people who may be physically co-located or may be dispersed are working together on a larger, typically scientific question, or they're contributing to a larger project. And often, collaboration, especially collaboration around data, is fundamental to that. So being able to do a quick analysis, share it with someone with more expertise than you to get feedback, doing some additional work on it, or combining two different data sources together, things of that sort. And that's difficult, I think, as you all know, especially for researchers who are not part of large universities like the University of Michigan, where we take for granted a lot of infrastructure to support our data. And even then, has anyone ever complained about the infrastructure? Never. Okay, that's what I thought. So that's partly who we're aiming to. And then, as I said, people who do not have this reliable cyber infrastructure for sharing or analyzing their data or publishing it or knowing where to put it when they've finished extracting as much knowledge of it from it as they can. And it kind of goes along a continuum from citizen scientists to research centers, large research centers that still have fixed year funding. They may have support for 5 years or 10 years, but at the end of the day, when the funding runs out, they may have very valuable data resources and no clear resources or capability to sustain those resources into the future. So SEED right now stands for Sustainable Environment Actionable Data. And that is because we started our work with researchers who are doing sustainability science research, because it's a particular community that uses multiple types of data. They have many, many different kinds of measurement systems. They need to combine variables, often in time series. They have a lot of need to identify geospatial locations of their data. So it's a kind of complex data problem. and also typically a community that where the research can cut across all of these different kinds of venues. So I want to just now quickly kind of run through what SEED offers and talk a bit about some of its features. So the way that SEED works is that we provide research projects or groups or even individuals something called a project space, which allows you to easily upload data. It's supported by an infrastructure that has, viewers for many, many different kinds of data. So if you want to review a video, you can launch it right in your browser. You don't have to download it and load up another plugin or application to see it. You can get geographic overlays of where your data sets come from. And we have a lot of powerful tools to extract metadata from a whole wide variety of files. I'm not going to go into details about that, but I certainly will answer questions about it at the end. And that's what the kind of active curation is. Not only do we extract as much metadata as we can find about a file, so things like its type, when it was created, how big it is, what format it's in, and in some cases, more content-specific metadata we can extract. We also make it easy for people using the data to add metadata, to comment on files and data, and we continually accumulate that additional metadata and insights about the data as the scientists are working with it. We track the provenance of data, so when a new file is created as a version of two different files, for example, we track back to the source where they were extracted from. And we have some easy plugins to external analysis software. Not as many as we would like to have yet, but for example, we have a way in which you can run an analysis using the software package R and then capture the results of that and keep track of what data was run through the analysis and how the results relate to that. And we have visualizing tools for geospatial data. That's just some examples. I think the point I just want to make clear is that, at least for now, the project spaces are free, they're secured, and they are self-managed by the teams. We are providing data management services, and we like to say SEED is better than Dropbox because it's not just a place to put your data. It's a place to help you manage it, share it, and archive it. And we provide tools that actually help groups implement their data management plans. There's a lot of advice and guidance and help in writing a data management plan, which is a requirement now for any federally sponsored grant that you submit. But once your grant is approved and your data management plan is to be put into effect, often it's sitting in a file somewhere, and when the project is finished, it's like, oh, okay, now we have to do our data management plan. SEED is trying to make that a much more seamless process. And as I said, we capture value-added metadata throughout the process. In terms of our curation and preservation services, SEED is not a repository. SEED provides services that allow researchers to identify an appropriate repository for their data, to package it, and to send it off to that repository, which may or may not do additional curation on it. and to accept the terms and conditions of what the repository is providing. So we have, you can publish directly from a project space, or if you are finished with, you didn't have a project space in Seed, but you have data you want to publish, we have a staging area where you can assemble a package of the relevant pieces of your research that you want to publish. And that can be a subset of data files. It can be metadata or documentation about the data. It could be scripts that you use to get some of the results. And then we have a matchmaker service that helps the researcher decide what's the best repository for my data. And right now we are working with a DSpace repository at Illinois called Ideals, the IU Cloud service, ScholarWorks at Indiana, ICPSR Open. We've had some interaction with the Digital Preservation Network, and we're working with the Fedora 4 repository, which, and for many of you aren't in the repository business, this won't make a lot of sense. But these are very common architectures that take data in, require some standardization of that data, and attach metadata to it so that it can be discovered and reused. And there are, a number of different architectures. We'd like to work with any kind of repository architecture that's out there.
Are there any that are HIPAA compliant, or are all places pretty on their own for that?
So the HIPAA compliance is, I'd say, independent of the repository architecture, but there are repositories running on things like Fedora that have a set of policies, procedures, security, etc., that are HIPAA compliant and FSMA compliant. And those are often, separate so-called enclaves for data. The details of HIPAA and FSMA compliance are not something I'm deeply familiar with, but I should say right now, we are not working directly with any repositories that are HIPAA compliant, but we're looking at moving in that direction through the virtual enclave that ICPSR supports for some of its data. So, or that it interoperates with. Okay, just quickly, in terms of when you're ready to publish your data, we have a formal publication process, which involves packaging, as I mentioned, pulling together the relevant pieces of data, assigning persistent identifiers, and sending it to a long-term repository, and then registering those packages with a whole variety of discovery services. So if you want to expose your metadata so that search engines of many flavors can discover it, Seed makes it easy to register those packages with those services. Okay, I just want to give you this is like a high-level overview of how Seed works. And as I said, we do not produce, there's a pointer here, we do not produce or maintain the repository side of it for long-term archiving. And there are limits to the whole variety of applications and tools and computational environments that we can work with. So this is the space in which Seed provides services. And the project spaces have a curation workflow where we're extracting metadata and researchers are adding metadata as they're working with their data in their project spaces, or coming in from the outside and moving directly into the matchmaker service. And then we have a whole number of registry services that we interoperate with. So persistent name identifiers. How many of you have an ORCID ID? Does anyone know what that is? Okay, so if you have an ORCID ID associated with your data, we use that, register that. Whatever you publish through Seed automatically gets added to your ORCID profile, and there's lots of different growing number of registry services of this type. And then the matchmaker provides, at this point, it's not like an automatic thing, but it provides you as a researcher with options for which repository to put your data in. And for example, being HIPAA compliant could well be one of a researcher's requirement. And if Seed does not have any repositories at the moment that are HIPAA compliant, then we can't help you, right? But you would be aware of which repositories are HIPAA compliant. So that's kind of the way we're addressing that problem. I just walk through a kind of a quick feature tour. So you can very easily get a project space, and if anybody wants to get a project space and play around, we also have a demo space. Just go to our website, which I will, put up prominently at the end. And I also have some literature about our different services. So a project space manager or owner can invite people to join the project space. They can assign roles, so who can look at data, who can edit data, who can add data, who can download data. Those can be controlled to the norms and requirements of the project. You can control which data, if any, is available for public viewing. You can brand your space with your logo or your project name or whatever, which is something we hadn't anticipated but turned out to be really important to people. It's like, we don't want to lose the identity of this data that we produced and our project. And then we are building the capability for you to have customizable ontologies or metadata standards or data models that your project space can support. In terms of what you can do in a project space, I think I mentioned most of this, but you can load any kind of data. We're agnostic about what format it is. If it's in some very unusual format, we may not have viewers for that yet, but we're, working on developing more and more of those. And I just want to mention, in terms of active curation, you can actually comment on data. So if you're part of a team and someone shares a numeric data set with you, and you don't really understand how they defined, variable Y, you can ask, and someone can add a comment, and that gets accumulated with the data. And it's that kind of, deep knowledge of data that we are trying to capture, because really the people who work with the data are the ones who know it best, typically. As I said, we've worked a lot with geospatial and time series data. And we have, in your project space, you can zoom in on data, you can represent it in any number of viewers, you can download it, you can delete it, you can embed it in another file or whatever. And then when it comes to publishing, you can submit collections, and we have actually now published a collection with over 100,000 files in it. And your published data will appear with things like a standard citation, an abstract, your logo if you want it, and things of that sort. And then,
So
yeah.
the data is actually off at some repository, correct? So for these visualizations, are you actively doing queries on those repositories in order to generate like the graphic displays?
What we're trying to do, we don't delete anything from the project spaces. So if you have a digital object identifier that goes with a set of data that requires a visualization service, by tracking the provenance, we can route you back to where it resides in seed. A copy of it resides in seed in the project space. And at the same time, it's kind of trying to nudge the repositories to think about having a broader range of tools for researchers to actually do something with their data.
So people have really big data sets. You have to maintain a copy for this work?
We're working on that. Actually,
Talking to Brian.
yeah, exactly. Right now, we don't have a big issue. We are fortunate to have a pretty big allocation at Indiana in the IU Secure Data Archive or whatever it's called.
They have the infrastructure.
Yeah. Mostly what we encounter is not enormous files, but enormous collections. So we have a collection, it's only 1.4 terabytes of data, but it's 500 and some thousand files. And file systems kind of break when you have that amount, that number of files and variety, and then yeah. So that's more a long tail problem, and that's the kind of thing that we've been looking at. But super huge files, they would need to be replicated somewhere. You wouldn't want to just have one copy of them, even if they're really huge. And we are working with things like this emerging national data service, which is looking to provide on a national level high security, high density data storage. And so we have actually a pilot project pushing some things out to them. So anyway, I hope that answered your question.
The answer is we do have options.
Yeah,
You know,
exactly.
Good base already. So I don't think it's a problem.
I'm not worried about the storage part, really. I'm worried about the usage and the dynamics and all of that. So I just wanted to just stop. Oh, go ahead.
I just have a question about the matchmaker.
Yeah.
So the repositories, is there metadata about the repositories that then advertise their capabilities back? Okay.
Yeah.
And
Yeah. And we're working on some basic rules. I mean, the matchmaker, we have a kind of proof of concept, and I can't find it right now, but I could show you a demo of how it, what it looks like and what the rule base is. But the repositories have constraints of things like we can't take a file that's more than 500 gigabytes, and we only take these 5 formats, and we require this basic metadata in order to deposit the data. Now, what happens with we have a workflow, we have a sort of messaging bus, and we have a workflow, and in the staging area, there's a process, and one can identify what appears to be an appropriate repository. They can submit it to that repository, and then we have ways of checking whether the data actually conforms to what we know the rules are. And it can bounce back to you and say, you need to add the geospatial location where the data came from, or something like that. So yeah, it's a back and forth iterative process. So it's not like I throw my data over the wall And maybe in 6 months, someone will come back to me and say, oh, well, there's these things missing from the code book, you know, and we're trying to make this a much smoother, much more continuous flow with, you know, some regular feedback loops along the way.
And you were talking about keeping a copy before replication. Do you want to keep a canonical copy of this? Is there anything to prevent me from sending it to 2 repositories?
When it's published, it gets a digital object identifier as something called a research object. Now, you can only assign one digital object identifier to one object. That's kind of the point. If one wanted to, I mean, one could send pieces of it clearly in different combinations, if that made sense. And we've talked a lot about, you know, what does it mean when there's, you know, like a complex digital object out in a repository and someone wants to bring it back in their project space, decompose it back into its component parts and do some more work on it. Now, we will track the provenance back and forth, but if they produce a new object from that, that's going to get a new digital object identifier. Okay, so I just want to say a little bit about what I think SEED's unique contributions are. So we've actually developed kind of an end-to-end workflow or flow of data. From the point you design a project and set it up and start collecting and analyzing data, all the way out to depositing it in a repository for long-term archiving or publishing it with a publisher. And that's important, I think, because there's been a lot of discussion. I should say I actually come from the archiving community for years of we have to get the scientists to make their data in such a way that it will be possible or easy for us to archive it. And the scientists, on the other hand, are like, I'm doing my science, and when I get around to it and need to archive it, I will worry about that. And we're trying to, and so there's really often pushing work back and forth from one side or the other of this. It's like, well, if I don't do it and you want my data, then you can invest lots of time trying to straighten out my mess. Or, yeah. So anyway, we're trying to get that, rather than being 2 processes that kind of intersect, to make it a much smoother flow with a lot of the added value that scientists provide when they comment on data or they select certain data to move forward in their analyses with. I mean, all of that, those kinds of processes which are part of curation, we want to capture that value added as it goes along. And then when you have data to deposit, it's a much richer, better documented, more easily understandable product. So, as I said, we have also tools to help implement, not just to write data management plans, but to if you've got your data management plan, we can provide support to you to build the implementation into the way you do your regular work. Ability to handle multiple formats and file types and schemas, and then giving researchers a choice of repositories, because it actually, you know, back in the old days, there typically was, here is a logical place for me to archive my kind of data for my community. But there's a growing proliferation of options. So do I put my data in a domain repository? You know, I think many of you are in bioinformatics, but do I deposit it in a particular, you know, data bank, sequencing data bank? Do I deposit it with my paper with a publisher? Do I put it in Figshare, you know, or whatever? And so this landscape of, you know, it's obvious where you want to put your data has changed vastly, and researchers do have choices, and repositories have widely differing capabilities. So we're trying to see what we can do to take advantage of that environment rather than just assuming that everybody has to operate in the same kind of standardized way. So,
Is this hooked up at all to NCBI?
no. I should say it could be, I think. Because in our sort of first round of funding, we were focusing on sustainability science. We haven't done a lot with, we have a little bit, we have some biological data, but we haven't done a lot with kind of life science data. And part of it is the HIPAA kind of issues. But there's nothing in the architecture that would make that impossible. And as we move, we're about to release seed version 2.0, which is a different underlying architecture, same kind of principles, but a different underlying architecture. And I won't bore you with the details, and actually I don't know all of them. But when we do that, I think we're going to call it science enabled through access to data. And it won't be seed as it's been anymore.
Is it using any international repositories, or are they US based? I think some fields.
Yeah. We are not using any repositories that are not based in the United States, I guess I would say. But we are working with repositories that have data from many different countries. Okay, and then I just wanted to say, you know, before we close for questions, this is our website. That's our email. We have Twitter, we have Facebook, whatever your preference is. And you can also, oops, I'm going the wrong way again. You can also try seed or request a space if you want to check it out and see what it will do for you. So now I guess I'd be happy to take any questions, Jake.
So I guess I'll follow up on the sort of line of questions that you were asking. I'm from the library, and we are about 2 weeks or so away from doing a soft launch of data repository of our own.
Mm-hmm.
And so I'm interested in the process by which you connect to repositories. What would you look for in terms of making those connections, and how can we partner with you to become one?
You can talk to me afterwards. But you're using Hydra Fedora, yeah, right? And we can connect to that easily. The issues are usually more around kind of the policy questions, but at this point, we would ask you to express what your capabilities are and what your requirements are in a formal way, so we can connect you to the matchmaker. We already have that for the institutional repositories at Illinois, so it'll be kind of interesting. And I think this may be a little arcane for you who aren't in the archiving repository world, but institutional repositories are designed to, correct me if I'm wrong, capture the intellectual and scholarly output, or creative and scholarly output of the faculty, at a particular university. We have people like, let's say the SEED project, for example, where people are producing scholarly output at Illinois, Indiana, and the University of Michigan. And so what does it mean if you're going to deposit into whatever? It's not Deep Blue anymore, it's something.
Deep Blue Data is the name of the repository.
What's it called?
Deep Blue Data.
Deep Blue Data? Yeah, Deep Blue Data. So do I do it? Do I do it to Deep Blue Data? Do I do it to Ideals? Do I do it to ScholarWorks? And so those kinds of, policy issues are things that come up. Yeah.
I really like the fact that you're doing this, and the Matchmaker service, I think, is really a critical component of just letting people know what their options are.
Yeah.
And to see what the different services and requirements are to
Yeah.
make informed decisions.
Yeah, I mean, part of what we've done in terms of archiving and the whole philosophy is we have unbundled what a typical repository would do into a whole set of services. And the idea is that, if somebody's really good at storing very large objects, they don't necessarily have to be really good at discovery services or search or delivery or visualization. And, in my view, in the big picture of things, decoupling these services and allowing them to interoperate is going to be much more efficient than every time we have a new data type or a new community adding yet another repository that does its own job of discovery, storage, ingest, curation, and the like. Yeah, so that's kind of the philosophy that I have. Yes, sir. Hello.
I guess I'm kind of curious to how you enforce quality of data. I could very quickly see this becoming a whole bunch of people's junk hard drive space where they just throw stuff there because they don't want to delete it. And yeah, so are there any? I mean, do you guys have limits on how much space a user can use, or?
Well, right now, if you want to have more than a terabyte in your project space,
Right.
Especially since we have a limited amount of storage, we I think we do set an upper limit on how much space you can have for free. We have not yet designed or implemented a policy or process to flush the project spaces, so to speak, of things that are, version 3 of 50 versions of the same thing. But yeah, at the moment, at least where SEED is in its development, it's more work to go out back and sort all those things out than, to just store the stuff. But it's very likely that, if a project finishes up, they publish their data to a repository, and then there's no activity for 5 years or something, that it might make sense to go back to them and say, do you really want to keep this? And at the moment, that may be kind of where we will land.
Is that a good standard though? Asking the person after things have been published and the whole questions of reproducibility. You never know when someone out in the community might want to go back.
Well,
I don't expect an answer on that.
no, I mean,
I don't know what journal standards are, because this is all part of actually data management. Data management plan and what are required lifetimes for things. Exactly.
And I mean, that will vary context to context. So, I was giving that as an example, but I can imagine that there would be many other kinds of principles. And one of the things that we've encountered in the geospatial area, for example, is that a lot of the data we're getting are what we would call hybrid or derived data products, where a researcher is, or a team of researchers are interested in soil conditions at a particular geospatial location. They go out to USGS, they get baseline data, they go to USDA, they get soil data, they go somewhere else and get hydrological data, they go somewhere else and get meteorological data, and they munch it together and then add some things to it. And we did this with actually a large center, this one that's got the 500,000 files. And at some point, it's not going to make sense for every repository to store every combination and permutation of data extracted from these large reference databases, which is something we're trying to do by like tracking the provenance of where the data's come from. But that, I should say, I see that as an issue, but there's only so much you can do with $5 million or $8 million. We had $8 million. And to get a stable system with a reasonable set of services and I think we have about 40 projects that are using it right now. So.
Any other questions?
Brian, are you? Yeah, ask Jake.
Could you tell us a little bit about what the library is launching?
Sure. So we're really looking at how can we, as Margaret said, there's a number of issues that are coming down the pike with the need to better manage, better organize, better describe one's data so that others can make use of it, to put your data out there so others can get a hold of it, to sort of look at the work that you've done and be able to sort of determine, where are you coming in with your findings, but also to put it out there, again, as Margaret said, to enable it to be reused or repurposed by others to advance the particular field. And so the library really is looking at building a suite of data services that can hopefully help researchers consider those issues and act on them through the kind of skills and knowledge and perspective that we have as librarians to help people produce data sets that can be consumed by others to fulfill these kinds of requirements. And so one of the things that we're doing as a part of that is to produce this data repository to enable folks who, here at Michigan, as Margaret said, our community of practice really is the University of Michigan. So rather than ICPSR, for example, or even SEED, which is focused on a particular discipline, sustainable environment or social sciences, we are really looking to try to create a platform for folks who don't have a domain repository that's active or it's not appropriate for whatever reason, to still have an option for complying with the funder mandates or with the desire to share one's data in ways that, what's that?
That's just about everybody.
That's a lot of different folks, yeah. So I think different communities of practice are sort of at different places with understanding how to respond to these requirements, with developing standards or guidelines for doing so. And so our job really is to, when they exist, to help connect people with those particular resources or tools so they can do what they need to do. When they don't exist, are there things that we can do to help guide or inform folks as to how they might want to respond? And can we produce options, again, for things like sharing data or preserving data through resources here at the University of Michigan?
So, I think attaching your service to SEED would be a great way to help people understand the landscape of choices that they have.
Mm-hmm.
Yeah.
Yeah.
So that means you're going to do a demo?
Am I going to do a demo? I'm not going to do a demo. Because I didn't put it on my flash drive. So.
Okay, anything else? All right. Well, great to have you back.
Okay.